Okay, so we have to take this graph of h of x, right? So this right here is h of x, and we have to graph k of x, which is negative h of x plus 2 quantity minus 3. So the difference, what makes this trickier than the other questions, is that we don't have an equation. All right, with the other questions here, when you have like, oh, graph y is equal to x minus 2 squared plus 3, like if you don't know transformations, you can actually get away with graphing this because you can always just plug in values for x, see what y is, and then plot those points. You don't have that luxury here because it's not an equation. It's a function which we only know as a graph, all right, and then we have to graph another function which is that transformed. So I'm going to do a longer explanation first, and then show you how it ties to the transformation. So if you're doing this, you don't have to do this first part I'm about to show you. You could just jump right to the transformations. Alright, so first thing I'm going to do is plot some points on x. So for x and h of x, there's the point 0, 1. Okay, there's the point 1, 2. There's a point, we'll say here, negative 4, 1. And we also got a point here at 3, 8. And another one over here at negative 7, 3. Alright, so there's some points right there on h of x. Now let's make a table for k of x. So I'm gonna kind of run out of room here. Let's do it right around here. Alright, so we got x, and then we got k of x. Really, hold on 1 second. Alright, sorry about that. So I just rewrote that table, and now I'm making a new table for k of x. So remember, k of x is in terms of h of x. So here's where h of x is defined for. It's defined for those x values. Okay, so I need to plug in x values that will make what's inside these parentheses equal to these x values, because those are the only 5 that I have it defined for. So what do I mean by that? Well, I'm going to first plug in negative 9, because I know that if I plug that in to k of x, remember right here, I get negative h of negative 9 plus 2 and then minus 3. Alright, so that's equal to negative h of negative 7 minus 3. Okay, so I plugged in negative 9 because I knew when I added the 2 I would get negative 7. And I know from this table here that h of negative 7 is equal to 3. So now I could plug 3 in for h of negative 7. And so now I have negative 3 minus 3, I get negative 6. Alright, so my point, negative 7, 3, which was right here, got transformed, got moved to the point negative 9, negative 6. So let me plot that point. So negative 9, you can't even see it, but it's going to be like negative 9, negative 6 is going to be like somewhere over here. Alright, now let's do that again. So now let's plug in the next point, which would be 2 less than negative 4, so negative 6. So if I did negative h of negative 6 plus 2 minus 3, I get negative h of negative 4 minus 3. And I know from here that h of negative 4 is 1. So it's negative 1 minus 3, which is negative 4. So I now have the point negative 6, negative 4. Okay, then let me try that again. So now I'm going to plug in the next point, which is going to be 2 less than 0. So negative 2. So I get negative 2. So k of negative 2 plus 2. That's a negative. Sorry, I messed that up. It's remember, I'm plugging it in to k, so it's this up here. So it's negative h of negative 2 plus 2 minus 3. So that's negative h of 0 minus 3. Okay, h of 0 is 1, so negative 1 minus 3 is negative 4. So I have negative 2 and then negative 4. Okay, let's do another one. So 1, so I got to plug in something 2 less than 1. so negative 1. So I get negative h of negative 1 plus 2 minus 3. So negative h of 1 minus 3 would equal negative 2 minus 3, so that's negative 5. So now I have the point negative 1, comma, negative 5. Alright, and then last but not least, I got 3 here. So if I plug in 3, so I got to plug in something 2 less than 3, so 1. So I get negative h of 1 plus 2 minus 3. So negative h of 3 minus 3. So that's negative h of 3 is 8. So negative 8 minus 3. So that's going to be negative 11. So I got the point 1 comma negative 11 somewhere down here. Alright, and there is my graph. Now, how would I do that with transformations? Alright, well, the transformations were take these points, these purple points, and we're going to reflect them over the x-axis. Okay, so let's take this point for example, reflect it over the x-axis. Then we're going to move it 2 to the left and then down 3. Bang. So there's that point. Or if I took this point and I reflected it over the x-axis and then moved it to the left 2, down 3, we would be right here. Or if I took this point, reflected it over the x-axis, moved it 2 to the left, down 3, we would be right here. Alright, if I take this point, reflect it, 2 to the left, down 3, right here. This point, reflect it, 2 to the left, down 3. So, see how that second way was a lot quicker? If you just know these transformations, you could just take a couple points on the original graph and then apply them. So, reflect and then translate at the end if it's in standard form. Alright, so there's 2 ways how you could do this, but I think this first way kind of shows you like how these values here affect these numbers in this table and thus graphically make those transformations.